Okay, so we're going to continue with the polynomials. So for this lesson, again, this is the second part of the lesson of sum and product of the roots. So in this lesson, I'm just going to keep trying different type of questions. And so hopefully I can present as many questions as possible. I'm just going to pick the question from the textbook. All right, so let's just start. The first type of question, we'll just say example 1. Okay, so I'd like to show you the first type of question they're going to give it to you like in exams, all right, for the year 11 exams. So this is from exercise 10F, question 2. And I'm just going to pick a few questions from question 2 to do the question. So the question says, if alpha, beta, and gamma are the root of the equation x to the power 3 plus 2x squared minus 11x minus 12 equals to 0. And then the question says find. For the first one is alpha plus beta plus gamma. And question B is alpha beta plus alpha gamma plus beta gamma. Question C is alpha beta gamma. So these are the very basic, elementary style of question. And then it asks you to find out what is 1 over alpha plus 1 over beta plus 1 over gamma. And question A is 1 over alpha beta plus 1 over alpha gamma plus 1 over beta gamma. And then we'll move on to question F. So there are quite a few questions there. Alpha plus 1, beta plus 1, and gamma plus 1. And then we've got question G, alpha beta square gamma plus alpha gamma square beta and beta gamma square alpha. And the last one is H, alpha square plus beta square plus gamma square. Or actually, that's the second last one. So alpha square plus beta square plus gamma square. And the very last one is alpha beta to the power of negative 2 plus alpha gamma to the power of negative 2 plus beta gamma to the power of negative 2. So here's the question, right? So I'll actually do all of the questions here, and I feel like those questions are very it covers everything that you need to know, and probably is going to do another one. I will just do one more as in a special case, okay? And that's not in the exams. That's not in the textbook. Sorry, that's alpha to the power 3 plus beta to the power 3 plus gamma to the power 3. Okay. All right, so let's start. Let's start with the first one. In order for you to actually find out the first 3, that's just a formula. So this is easy. All right. Okay, so we'll start with the first question here. Alpha plus beta plus gamma is equal to minus b on A. And then according to the question here, I'm just going to actually copy this question down as it's easier for me to refer to that question. Okay, so here we go. So that's the question. All right, now we know it's alpha, beta, b and a equals 2. So b is just a number in front of the x squared. And then a is, and a is the coefficient in front of the x to the power 3, the leading coefficient. So in this case here, the answer for that will be just negative 2 over 1, which is minus 2. Okay, so that's alpha plus beta plus gamma is equal to minus 2. Okay, all right. I'm just going to rewrite it. That's minus 2. Now remember, we are going to use those results later, okay? Use these 3 results in the later questions. So that's the reason why usually in a question, they will scaffold the question for you. They're going to ask you to find out the first 3 things first. All right, otherwise if they don't do that, all right, you need to find out what's the first 3 formula equals to. Next one, alpha beta plus alpha gamma plus beta gamma is equal to C on A. And in this case here, C is equal to minus 11 over 1, so that's equal to minus 11. Okay, so first one is minus B on A, the next one is C on A, positive. All right, so you end up with a negative result because one of the C is actually negative, so negative 11. All right, so the last one is alpha beta gamma is, all right, so this is minus B on A, this is C on A, this is minus D on A again, okay? Now D in this case here is equal to negative 12, but it's minus D on A, so therefore it's minus 12. So at the end, the answer is equal to 12 over 1. All right, so we've got the first 3 answers here. Extremely important, okay, for the first 3 answers. We are going to use these 3 answers to solve later questions. All right, so now we're going to move on to question D. So how do we solve questions like those ones now, where you need to use your algebra skills to simplify this expression, where this expression can be a combination of, the terms above. All right, so this is the idea. You need to simplify what you have here. Hopefully, when you use your algebra, you're gonna see that it can be simplified in terms of those, maybe one of them, or all three of them, or maybe two of them. But you need to use some of those results to find the answers here. All right, so for question D, just going to do it step by steps. First step, obviously, you need to combine the three fractions together. So making the same denominator, alpha, beta, gamma. For the numerator, you get a beta, gamma plus alpha, gamma plus alpha, beta, which then it tells you that for the numerator here, it's just the middle term, which is negative 11. For the denominator, that's just alpha, beta, gamma, the product, and that's equal to 12. So therefore, 1 over alpha plus 1 over beta plus 1 over gamma, without actually solving the solution for alpha, beta, gamma, the relationship is negative 11 over 12. Okay. Now, by the way, with those questions here, usually, if that's the type of question, you don't need to. You don't supposed to find out what's alpha, beta, gamma. So you're not supposed to actually solve this equation and find out what is the alpha, beta, gamma, and then you just simply do a substitution there. No, you're not supposed to do that. All right. So you're supposed to use the root and coefficient relations to do the question. All right. Question E. 1 over alpha beta plus 1 over alpha gamma plus 1 over beta gamma. All right, same thing. I feel like this question is the same. We're just going to make the same denominator, which is the alpha, beta, gamma, and then we just need to find out which term is missing from the each of the denominator. So that's what we get. All right, so in that case, for the numerator, we've got the sum of the roots, which is -2. For the denominator, it's the product of the root, which is equal to 12. And then at the end is equal to 1 over negative 1 over 6. All right, so that's question E. For question F, okay, question F. Question F, you've got alpha plus 1, beta plus 1, and gamma plus 1. You need to find out these results here. So again, you've got factors here. What you need to do is try to expand and simplify, so therefore you can get one of the terms above, or maybe two of the terms above. Then you can do some substitution inside. Okay, so it's going to be a bit annoying. You just have to step by steps expand term by term. So let's just do that. Okay, alpha beta plus alpha plus beta plus 1 gamma plus 1, alpha beta gamma plus alpha beta plus alpha gamma plus alpha plus beta gamma plus beta plus gamma plus 1. Yep, I hope everything's right. Now, once this is correct now, if you assume this is correct now, these three terms are just the product of the roots, and then these three terms are the sum of the roots, and the last one is actually this three term is the product of the three terms together. So you have everything you need. Okay, so that tells you that the product of the term is equal to -2 from the above one. Oh, that's not -2. It should be positive 12. Yep, you just have to make sure that you actually check very carefully. Don't make any silly mistakes here. All right, so that's actually 12 plus. Now, if we group these three together, okay, that is equal to -11. All right, so we can just -11 here and plus. And then if you group these three together, okay, these three alpha, beta, gamma, it's -2. That's -2. And the last one is just +1 at the end. All right, so once you finish this at this stage, then it's just pretty easy calculation. 12 minus 11 is 1. 1 plus 1 is equal to 2. 2 minus 2 is equal to 0. So at the end, the answer is equal to 0 for question F. All right, question G. All right, so what I'm going to do is probably just copy everything down and then move on to the next page. So I've got all the information there. Okay. All right, so now we can move on to question G. Question G is alpha beta square gamma plus alpha gamma square beta plus beta gamma square alpha. Now it looks pretty interesting here. what is the best way to actually do this question? Okay, so I'm just thinking about how do we factorize this, or can we factorize it properly? All right, if we do factorize, if we take alpha, beta, gamma out, if we factorize everything out, let's have a look at what's going on inside the bracket. I'm not really sure. Like, I don't know if this is the right way of doing it, but let's do it, okay? So before we factorize, let's just expand, all right? Just don't want to see all this, square. All right. Okay. It does look like, if we have a square here, a square there, and a square here, it looks much better because we do have alpha, beta, gamma is equal to 12. Then if each of the term has a square in it, that will be perfect. And then, all I have to do is just simply, square this term, and then we plus them together. So I'm thinking about, can we times this by that? If we times the entire term by alpha plus beta plus gamma, what am I going to get? Okay, but it looks like it's not going to work that well. Okay, all right, so in this case here, I kind of like just still focus on the method I was previously thinking about. Just, factorize alpha, beta, gamma out. Okay, let's see if that's going to give us a very nice answer, hopefully. That's alpha, that's gamma, great. Looks promising here. That's beta, that's gamma. All right, perfect. So if you just factorize the alpha, beta, gamma out, you end up with the product of 3 terms and the sum of the product of 2 pairs. All right, so now we can just do a substitution. That's 12 times by negative 11. Using a calculator, the answer would be negative 132. All right, that's what G is. Okay, now question H. Alpha squared plus beta squared plus gamma squared. With question H, this is a bit tricky here for this question. If you want to do the square, if you want to do a question like this one here, I guess the first step you need to do is sort of derive a formula for those sum of the square of each root. And then later, once you derive the formula, later you should memorize the formula, okay? So I'd like to show you the deriving part of the formula. If we know that, if we just let this one square, all right, now remember these two are not equal to each other. They're not equal to, I'm just start with a brand new sort of like expression. I want to make sure they are equal, they are not equal to each other, but I want to just try to expand what's this one equals to, okay? If we expand that, I'm just going to break down it into 2 parts. Actually, probably just do it below so I can show you what's going on. Do we have the space? Probably don't have any space here. Here we might. Okay. All right. So what I really want to do is show you on, in a single line. All right. So the way to do that is you actually group this one as, as a group, as one term. So that becomes quadratic expansion. Okay, the perfect square for quadratics. So that gives you alpha plus beta square plus 2 lots of alpha plus beta times by gamma plus gamma square. Like that. So then if you keep expanding, alpha square plus 2 alpha beta plus beta square plus 2 alpha gamma plus 2 alpha 2 beta gamma plus gamma square. All right, now if we combine kind of the like terms, not really combine the like terms, but grouping the like terms where the terms have all squares in it, you end up with alpha square plus beta square plus gamma square, brackets, plus 2 lots of alpha beta, alpha gamma, beta gamma. All right, so what does that really tell you? Hey, if you look at this, this is what we need to find, right? And which is here, okay? Which is just here. And remember, this on the right-hand side is actually equal to the terms on the left-hand side. And please also remember this. We know what's this equal to. We also know what's that equals to. So all we have to do is, if we substitute the value here and there, we can get the value here. So the formula itself is alpha squared plus beta, I'll probably use a different color. The formula itself that later you should remember, alpha squared plus beta squared plus gamma squared is equal to, which is that term here, remember, is equal to alpha plus beta plus gamma entire thing square, subtract. Now remember, you're going to move this term over to the left hand side, so that plus becomes a minus here. Subtract two lots of alpha, beta, alpha, gamma, beta, gamma. That should be your formula that you remember, and then you don't have to derive every single time when it comes to the question, okay? Right, so if you know that, then in this case, it's much easier. So we know what's alpha plus beta plus gamma, which is equal to -2, so we can square it. And then 2 times by the product of the, the sum of two pairs. All right, the sum of the product of two pairs, which is -11. So at the end, that becomes 4 plus 22, which is equal to 26. Okay, and that becomes the answer. Pretty easy. All right, let's move on to the next one, which is question I. So we've done question H. All right, so question I. Question I is alpha beta to the power of -2. Is that -2? Yes. Plus beta gamma to the power of -2 plus alpha gamma to the power of -2. Now, in order for me to solve this question here, what you do need to do is let's just turn that -2 as a power. Let's put it this way, into a fraction. Okay, so if we put that into a fraction, it looks much better. All right, then we can make it the same denominator, like alpha beta gamma square. And then we just need to add the terms that's missing from the, the denominator, which is here. And then have a look at this numerator here, or different numerator here. Is that the answer we had the previous one? Okay, so therefore, in order for you to do this question, you kind of need to do that question first before you can do this. So in the real exam, so they're not going to give you that question straight away as like the first question. Otherwise, you probably end up with this, and you still need to go all the way here to go through all these details here to find out what's alpha square plus beta square plus gamma square. So it will be a scaffolding question like this, where you have the result from the previous one, and then you got it, you can use it, right? So that becomes 26 over the product, which is 12, and then we square it. So that's 26 over 144, and that's 13 over 72. Okay, so that's question I. So once we've got the question I done, all right, the next one is how are we going to solve the one I give it to you? This one, the alpha cube plus beta cube plus gamma cube. I love to give the student this question here. I remember I give the student this question in the last year's Year 11 exams, and we don't get many responses. All right, so if you look at this question, it looks very similar to this. All right, so this is the confusing part of the students. They think they're quite similar. It's only different by just a power. That's a power of 2. That's a power of 3. So they were thinking about, hey, I'm just going to use the same method. Okay, so what they're doing in exam situation is they are deriving a formula like this. Okay, so they want to expand that, and hopefully the terms inside were containing alpha 3 to the plus beta to the power 3 plus gamma to the power 3, and somehow they can move something to the left hand side and complete the proof like what we did before. Unfortunately, the question is designed where this is not going to work that well. Okay. So it's not, that's definitely not the way to do this question anymore for the question with power 3. So how do you do it? There's a very special way to do power 3. Very, very special. So please learn this method. Okay? Very special way. And that special way comes from using the original equation of the polynomials. So what does that mean? I'm going to show you the working out, and hopefully you will understand what's going on. All right, I'll use different colors, so you'll probably understand more a bit more if I use different color. If we just say, hey, we let alpha, beta, gamma be the roots for the above equation, right? Now think about it. If alpha, beta, gamma are the roots, does that mean if I substitute alpha into here, here, and there, the right-hand side is equal to 0, right? Remember, alpha, beta, and gamma, they are the root, they're the solutions, right? So if we substitute like this equation will hold, right? This equation is true. And then if beta is also a solution, I can substitute beta inside. Do the same thing. Beta cube plus 2 beta square minus 11 beta minus 12 is equal to 0. And the last one, I can substitute gamma, right? Gamma cube, 2 gamma square minus 11 gamma minus 12 is equal to 0. Now remember, those three equations remains the same, right? They are true, okay? They are true. That's equation 1, equation 2, equation 3. The same sort of equations, you only replace the, x by alpha, beta, or gamma, but they still hold, right? The equation left-hand side is equal to right-hand side. They're the sort of root, so it must be true. So if this is true here, then what then we can do is we actually can combine these three equations together. So I'll show you what to do with combine these equations. All right, so let's copy this one down. All right, let's put it here. All right, so it means, the means about combining these three equations is I want to add these three equations together. Okay, don't be surprised, we'll add it together. So when we add them together, I want to actually factorize straight away. So look at this three. Look at this three. Is that the question we have, right? So if we just add them, all right, let me just highlight the things. We are going to add these three together, add this three together, keep adding this three, and then I'm going to add the last, this three, and then lastly, we can add those three as well. So what really happens is if you're adding 1, 2, and 3 together, we're going to end up with this. All right, so let's have a look. Let me just use a different color. We're going to end up with alpha 3 plus beta 3 plus gamma to the power 3, all of it, okay, plus 2 brackets alpha square plus beta square plus gamma square, minus, 11 brackets alpha plus beta plus gamma, minus, 12 times by 3. So it's like negative 12 plus negative 12 plus negative 12. So minus 36 is equal to 0 plus 0 plus 0, which is 0. Now back to the question. What does the question ask us to do? We need to find what is the result of alpha cube plus beta cube plus gamma cube, which is here. Then we have the result here from the previous question. We also have this. We've got all the stuff ready. We can just calculate all of this, move it to the right-hand side, and that's it. We're done. That's how we solve a question like that. That's what I'm saying. It's a very special way of doing the question. Very, very special. All right, is equal to 36 plus 11 alpha plus beta plus gamma minus 2 times by alpha square beta square plus gamma square. So you end up with 36 plus 11 times by the sum of the three roots, which is minus 2, minus the previous result, which is 26. Okay, and if we use a calculator, 36 minus 22 minus that, the answer is minus 38. Okay, so that is the right way of doing it. Please, next time if you see similar question, that could be a question where they, to give it to you as a, power of 4, maybe, or power, even quadratic power of 2, that's possible as well. This is the right way of going. Okay, please never try to expand these. Like I've noticed some students are actually doing something like that. They try to expand. You have millions of the terms there, and they're making silly algebra mistakes, and they just couldn't continue. All right. Okay. This is only the first type of the question. Okay, so that's just only example 1. First type of question we're using the sum and product of the roots. Now I'd like to show you a different style of questions. Okay. Different style of questions. We can use sum and product of the roots to actually solve equations. Okay, very easily to solve equations. All right. Okay, so I'm going to do question. Let's just call this as example 2. Okay, example 2. I would like to do question 7 from the exercise. Question 7. The question says, show that x equals to 1 and x equals to minus 2 are the zeros of the polynomials. Okay, are the zeros of px. And then the question says, use the sum and the product of zeros to find the other 1 or 2 zeros. Okay, so here's the question. All right, px or p of x. I'm just doing question D. 3x to the power 4 minus 5x to the power 3 minus 10x to the power of 2 plus 20x minus 8. I like to do this question like, well, actually, before this question, actually, no, not this question. I can leave this question for you to do. I'll do a question with power of 3. Part of the reason is I just want to show you the effect straight away. Oh. All right. Now, I hope you still remember from the previous way of solving, a polynomial equation is when we do some testing. All right, using this result here, it's going to be plus minus 1, plus minus 2, and then we just substitute them, and then once you have enough roots, you can just do a long division to work out what is the quotient equals to, and you can further factorize. That's the usual procedures, right? Now, after we've learning this product sum of the roots, or the root and the coefficient relationship, all right, then we can use this method to find the missing root, okay? So if we're already being told that, x equals to 1 and x equal to minus 2 are the zeros we just need to show, then the way to do that is much, much easier. All right, so all we have to do is just show they're the roots. So we show like P1 inside, okay? So let's hope P1 give us 0. So that gives you 2 plus 3 minus 2. Hey, that's equal to 0. And then we show P minus 2. That's 2 times by minus 8 plus 3 times by 4 plus 6 minus 2. Okay, and that's minus 4 plus 4, which is equal to 0. So therefore, we can say x equals to 1 and x equals to minus 2 are the roots. Now, once you get that information, if they are the roots, then before we learning this, all right, then the next step is you either try more roots, okay, you try more combinations to see if that works, or then you can start to do your long division, right? So you got your px, and then you got your x minus 1 and x plus 2, and you have to expand that, you have to do long division, and eventually get the results there. But now you don't need to do all of those, okay? We can use the root and the coefficient relation. What does that mean? Previously, we learned that alpha plus beta plus gamma is equal to minus b on a. Now, remember, we've already got 2 roots here. So you can call alpha is equal to 1 and beta is equal to 2. It doesn't matter. Okay? I'm supposed to highlight. All right, so this is that. And then minus 2 is just a beta. And then we have the result for negative b on a because we do have these two coefficients. All right, so we've got everything we need. So it's a simple substitution. 1 minus 2 plus gamma is equal to minus 3 on 2. And as you can see here, it's super easy to get the final answer. All right, so the gamma is equal to minus 3 on 2 plus 1. All right, so the final answer here is minus half. That's all. So now you've got 3 roots, x equals to 1, x equal to minus 2, x equals to negative half. And that is the answer to the question. You don't need to do any long division. No need to do anything. Okay, that's all. You're using the root and the coefficient relations to solve the question. All right, now for the previous question that I was supposed to do, question D, is when px is equal to degree of 4. Okay, now with degree of 4, it's a bit tricky because you have 2 solutions here. And with degree of 4, you should have another 2 solutions. So you need to use the root and the coefficient relations, and you're going to generate, possibly another simultaneous equation to solve it. All right, so I would like to do question D. P of x is equal to 3x to the power 4 minus 5x to the power 3 minus 10x squared plus 20x minus 8. Again, we just need to check. Remember, we still need to check P1, and we need to check P negative 2. All right, obviously the question tells us this is the root, so it must be equal to 0. Okay, so that is minus 12 plus 12 is equal to 0. Great. Next, P minus 2. Oh gosh. Now to save us a bit of time, we can just assume that's equal to 0. Obviously, don't do that in exam. It's a show question, so please show term by term. It's actually at least work out the answers there, okay? Don't just write down that's equal to 0. Okay, so therefore we can make a conclusion that x equals to 1 and x equals to minus 2 are the roots. All right, now, when it comes to this, then what we can do is we can use the root and the coefficient relations, right? We know that alpha plus beta plus gamma plus delta is equal to 5 on 3, which is negative b on, negative b on a. Okay, I'm just showing you what's going on, as you can see, which is 5 on 3, okay? And then you can, okay, so now we know it's alpha and beta equals 2. These are the two numbers there. So we can substitute. So we end up with like 1 minus 2 plus gamma plus delta is equal to 5 over 3. So gamma plus delta is equal to 5 over 3 plus 1. I think that's 8 over 3. Okay, if my calculation is right, that's 8 over 3. So now here comes the problem. We still can't solve this question, all right? We still have like 2 unknowns in one equation, so that's not enough. Then we need to use more root and coefficient relations, right? We've got more like choices, we've got other options. Then we can have like, 2 at a time, like this. Like that one, right? And then dot, 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 dot. We can have 3 at a time, like that. And dot, 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 dot. Or we can have the final one, okay? Where it's just the product of everything. Now, which one are you going to choose? Obviously, you're going to choose something that's easier, okay? I will choose the last one to do. All right, so alpha, beta, gamma, delta. I feel like this is much easier. All right, so how do I do that? Well, you need to remember the formula. That's minus b on a, c on a, minus d on a, e on a. So, okay, if you remember that, negative, positive, c on E on A, so that becomes negative 8 on 3. All right, so you don't have to write down the full setting of the formula. That's all you need to do. All right, so we know what alpha and beta equals to. That's 1 and minus 2. So that's minus 2 alpha gamma delta is equal to minus 8 on 3. So that would be 4 on 3. Okay, so negative 8 on 3 divided by 2 is 4 on 3. Yep. All right. Okay. All right. Okay. So now we got this. How do we solve that? Well, that's simultaneous equation. So now we can call this equation 1, equation 2, and we should be able to solve it. But then I've got a better way to solve this. I know you can use the simultaneous equation. You can make it alpha, or sorry, you can make it delta or gamma as a subject, do a substitution. But you can also do something like this, all right? This is the sum of the roots of quadratic. That is the product of the root of quadratic. So what does that mean is, we can have a quadratic equation like that. All right? We can have a quadratic equation like this. That's equal to 0. Obviously, if you don't want to do that, this is a bit too fancy for you, then don't do it, okay? Just do it properly. That becomes 3x squared minus 8x plus 4 is equal to 0. Okay, all right, so you just have to solve this question here, and hopefully you'll get the answer. That's 3, 1, 2, 2, minus, minus. Okay, that becomes, so as you can see, cross method is much better, okay? The PSF, terrible, don't use it. Use cross method. All right, that's it. You've got it. The x is equal to 2 on 3 and x is equal to 2. So now you have 4 solutions. Okay, the first solution, x1 is 1, x2 is minus 2, x3 is 2 on 3, x4 is equal to 2. Again, you're using this alpha, beta, gamma, delta, okay, method to find the remaining solutions. So you don't have to use a long division. But then, speaking of this, right, and then I was thinking about if that's in a real situation, the real exams, right, unless the question tells me to use the root and coefficient relations, I probably still gonna use long division, okay, to do this question. Just because I don't feel like this working out here is short enough for me to skip the long division, okay? I feel like a long division is slightly easier than this working out there. Well, as you can see, you still have to solve a simultaneous equation there. So it's not something that's really saving time, okay? That's what I just want to say. Okay, all right. Now, I'd like to show you one more time, and that should be enough for you to do the question in the exercise. Obviously, if you still, this exercise is pretty important, so if you have questions, make sure you let me know. So the next type of question I would like to do is actually a question starting from question 10, 11, those type. It's one, they ask you to solve they ask you to solve a polynomial equation, but they give you some conditions of the roots. So let's just put this as an example 3. And then question 10, okay? Question 10 actually. So the question says, find the roots or the zeros of the equation 3x to the power 3 minus x squared minus 48x plus 16 equals to 0. However, they also give you some condition. They're not just ask you to solve it without any conditions there. They give you that, given that the sum of the two of them is 0. So the sum of two of them, so the sum of the two roots, so you can just say the sum of two roots. All right, sounds really weird, given that the sum of two of them is 0. Anyway, okay, so that is the question. So they're given that the sum of the two roots is equal to 0. And then the question asks you to solve this. So how would you do this question? Well, we're going to use the property. In the textbook, they are going to say something about, hey, let alpha minus alpha and beta be the root. All right, beta be the root. My suggestion is don't. Okay, just because if you're using the same letter, okay, and you start to create your 3 formulas there, you will get confused. What I suggest you use is alpha, beta, gamma. Don't worry about the condition they give it to you. We deal with the condition later. So this is what you do. You still write down alpha. All right, so this is what you say. You let alpha, beta, and gamma be the roots. Okay, and then you know that, sum of the roots, sum of the two of them is equal to 0. So you can say alpha plus beta is equal to 0. That's all you have to do. Do not write one alpha, the other one is negative alpha. Obviously, they plus together is equal to 0 as well. But no, trust me, all right, you will get confused, especially when you start to create a formula, you'll get confused. Just ask yourself this question here, all right? Alpha, beta, gamma, delta. When you combine this, and that, using the pattern here, it's already complicated enough, right? Imagine, instead of writing alpha, beta, gamma, delta, they're all different. Imagine you're writing alpha, negative alpha, beta, and gamma, and you start to create the terms like this. You will get confused, trust me, all right? Especially when you do 3 at a time, you sort of forgot about whether you use this term and that term or not, so don't do that. All right, so once you finish that, you write on the formula. You write on all 3 of them. Not necessarily you have to use all 3 of them, but you write all 3 of them, just in case sometimes you do have to use it, okay? You write all 3 of them. I'm pretty sure negative 48 over 3 is equal to 16. Yes, I am correct. So that's negative 16. All right, then the last one is, that's negative, positive, negative. So that becomes negative 16 over 3. Okay, all right. So now you've got this information, right? Remember your aim is actually to find what's the roots. You need to find alpha, beta, gamma. You have actually 4. Not just 3, but you have 4 equations to help you. And that equation here is the most important. Alpha plus beta is equal to 0. Why is that? Well, if you just look at this one, that is equal to 0 now. So if I just call this is like equation 1, equation 2, equation 3, equation 4, we can just say, hey, sub equation 4 into equation 1. And what do you get? You get 0 plus gamma is equal to 1 and 3. You got the first one. Gamma is equal to 1/3. That's how easy it is. All right, so once you have that, then you can start from the equation 2. Alpha, beta plus gamma, bracket, alpha plus beta is equal to negative 16. Now, we know what alpha plus beta equals to. That's equal to 0. All right, so therefore, you have your second equation. Alpha beta is equal to minus 16. All right. Then you start from equation 3. Alpha, beta, gamma is equal to negative 16 over 3. Now, we know what gamma equals to. So, gamma is equal to 1 and 3. And in that case, we know what alpha and beta equals to. Well, that's a bit stupid. Okay, I'll show you why this is a bit stupid. I already have this result. I'm using the third result to prove this result, which I already have. All right, that's stupid. All right, what I'm supposed to do is I already have everything I need, which is that one and this one here. I should be able to find out the answer. Okay, all right. Now, how do I find this answer out? Well, there's another method called inspection. By inspection, okay, alpha is equal to 4, beta is equal to -4. Or alpha is equal to -4, beta is equal to +4. It doesn't matter with the order. Just because alpha, beta are just one of the roots, the order is not important. Can I use this method by inspection? You work out the answer here. Well, I guess in real exams, unless that's a proof question where you need to show working out, if that's the case, and if this is just a part of the question, yeah, why not? We can, by inspection. The sum of these two must be 0, and the product must be -16. Of course, one is 4, the other one is -4. So you solved. You have solved the question, and you have found all the 4 roots. First root is 4, second root is -4, the third root, or actually all the 3 roots, the third one is 1 and 3. The order is not important, so you can actually switch them around if you want to, but these are the 3 roots for that question there. Alright, so these are the 3 examples I would like to show you for using the sum and product of the roots. There are many other applications that you need to know how to do the questions, alright, and obviously it's impossible for me to show you every single type. I hope you are learning, you know the concept, and you should be able to apply the skills to the question. Alright, thanks for watching.